Hello, boys. Um, Greetings for all of you. Hope everything is going smooth and fine, and you're just being safe at at your home. As the situation demand, we are just staying at home, leaving our classroom, but we are just continuing our works. All of you are trying your heart and soul to just make a good preparation for all kind of exam, and already you have given an in-house model test exam, and at the end of this month you will sit for another in-house test. And online class is also going on. We were just reviewing several chapters, and in our regular class on our classroom we were just continuing with our last chapter, that means chapter 14, physics to save life. And I just gave some work to you, multimedia based work, making some groups, but unfortunately we didn't get chance to just to examine your works, or you didn't get chance to show your works, your team works. But as now we have no chance to get back to our classroom just now, so I will just try to review the chapter 14 in our online class. And let's start the class with chapter 14, physics to save life. In this chapter, the important topics we just started with the contribution of Sir Jagadish Chandra Bose, background of biophysics. The first topic was background of biophysics. You have known about background of biophysics, and then we had discussion on the contributions of Sir Jagadish Chandra Bose. So we won't continue this topic again. We will just try to focus on different kinds of diagnosis instrument. There are in this chapter some diagnosis instrument, and the discussion, the working procedure, the different parts of some familiar diagnosis instrument. So we will just try to know details about those instruments. First of all, we will try to know about X-ray. Though there was a discussion about X-ray in our regular class, but I just want to review the topic again here. What was the X-ray? In 1885, Wilhem Rontgen discovered this electromagnetic radiation. This is a electromagnetic radiation. This can penetrate through the muscles of the body and can create image on photographic plate. So what is X-ray? This is an electromagnetic radiation, and this can penetrating ability through the muscles of the body and can create image on photographic plate. So as this is a wave, this has a wavelength, frequency, and energy level. Let's just try to know about wavelength. The wavelength is smaller than visible ray. For example, 10 picometer to 10 nanometer. Frequency ranges from 30 petaHz to 30 exaHz. Peta, exa, picometer, nanometer. These words are very common to you, as this suffix, you have known about this suffix on chapter 1. So then energy level is 124 kilo electron volt to 124 kilo electron volt. So these terms or these ranges can vary in different types of X-ray. All X-rays are not of same type. For different diagnosis system, different X-rays are used. So their wavelength, their frequency, their energy level can vary according to which X-ray we are using. So next, working mechanism of X-ray tube. If we want to know about the working mechanism of X-ray tube, X-rays can be generated by an X-ray tube, a vacuum tube. This is a vacuum tube, which a vacuum tube that uses a high voltage to accelerate the electrons released by a cathode to a high velocity. You have known a little bit about anode, cathode, X-ray tube. If we just see the figure of an X-ray tube, everything will be clear to us. Here is a diagram of an X-ray tube, which contains cathode, anode. Cathode, what is cathode? Due to high voltage, electrons are emitted from cathode. Why they are emitted? There may arise a question, why the electrons are emitted from cathode. Because when high voltage difference is maintained in a X-ray tube, then excessive amount of heats are generated here, and due to heat, electrons are released from the filament or from the cathode, and there is another term named anode. What is the function of it? Is the high velocity electrons that are released from a cathode. These electrons just collide with a metal target, and this metal target is called anode. And due to this collision, X-rays are generated. In medical X-ray tube, the target is usually tungsten. That means as anode, tungsten are used in medical X-ray. If the electrons released by the cathode has enough energy, that means we have already known that cathode are used to release electron. So if the electron released by this cathode has enough energy, it can knock an orbital electron out of the inner electron shed of the target atom. Target atom is what? Target atom is an anode. So when an electron just collide with or just hit an anode, then what happens? From the outermost shell of the anode, some electrons are knocked due to the electron, and these electrons just leave their space and just jumps into the inner electron shell. So whenever if electron just leaves its space and just jumps to another orbital, then some energy releases here. This released energy are just emitted in the form of X-ray beam. Then electrons from higher energy levels try to fill the vacancies, and X-ray photons are emitted in this process. So if we just observe the diagram here, here in a X-ray tube, two electrodes we are using here. One is cathode, another is anode. Due to high voltage difference, cathodes after passing electricity through it, cathode gets heated, and due to this heat, so many electrons are released from cathode, and these electrons just heat the anode, and due to this heating, some electrons from the outermost orbital of anode jumps to the inner shell, and for that reason some energies are emitted here in a form of X-ray. So we have known about the generation process of X-ray. Next, we will just try to know about how X-ray is done. That means when a patient is recommended for an X-ray diagnosis, which way this X-ray is done. For doing an X-ray, the patient is positioned so that the part of the body being imaged, that means the part of the body that has to be examined is located between an X-ray source and an X-ray detector. The body of the patient is just located between X-ray source and X-ray detector. When the machine is turned on, X-rays travel through the body and are absorbed in different amounts by different tissues. All the parts of our body are not of same time, or the radiological density of all portions of our body are not same. So all portions of body don't absorb same amount of rays. So whenever the X-ray travel through the body and are absorbed in different amounts by different tissues, depending on the radiological density of the tissues, they pass through. Radiological density is a new term to us. What do we mean by radiological density? Radiological density is determined by both the density of that part and the atomic number. So which portion of the body has much radiological density that absorbs much X-rays? So for example, structures such like as bone of our body contain calcium, which has higher atomic number than most other tissues of our body. So bones readily absorb X-rays and produce high contrast on the X-ray detector. As the bones radiological density is much than other parts, other tissues, other portions of the body, so it absorbs much X-rays, and so it produces high contrast on the X-ray detector. As a result, the bony structures appear whiter. If we just observe on the image or an X-ray report here, the image of an hand. So the image of a hand here, the bones appear whiter than other tissues against a black background of a radiograph. Radiograph is what the report that is given for the diagnosis, for the examination of a doctor, for the diagnosis by a doctor. So on that report, the whiter the bones just appears whiter than other tissues, and the background is just immersed as black. Conversely, X-rays travel more easily through less radiologically dense tissues. As we have told earlier, bone is much radiological parts of our body, but the other parts or other tissues are more less radiologically dense tissues, such as, for example, fat and muscle, as they can absorb high energy rays. So these structures are displayed in shades of gray on a radiograph. So this is the process of doing an X-ray using an X-ray machine. So what are the uses of X-ray? We are just using X-ray, but what are the purposes of using it? Most of the time for determining dislocated bones, fractured bones, X-ray are done. Dislocated bones, fractured bones can be identified by doing an X-ray. To diagnose cavities of teeth by doing X-ray of the abdomen, intestinal obstruction can be detected. This is also major use of X-ray. For this purpose, we can also use ultrasonogram, but X-ray is also used. Existence of gallbladder stone and kidney stone can be detected using X-ray. Some other uses are mentioned on your book. You can just have a look on those points. For example, taking X-ray image of the chest, tuberculosis, pneumonia, lung cancer can be detected. X-ray can kill cancer cells, so it is used in radiotherapy for treatment. Those are some other points for what we can use X-ray. So we have known about X-ray, an important diagnosis element, and next we will just try to know about another diagnosis element called ultrasonography or ultrasound. Ultrasound or ultrasonography is a medical imaging technique. First of all, we want to know about ultrasonogram or ultrasonography. This is a medical imaging technique that uses high frequency sound wave. As the name ultrasound, from this we can just guess what happens here. High frequency sound waves and their echoes. So ultrasound are related to bats, whales, their movement. The technique is similar to echolocation used by bats, whales, or some other different kinds of animals. This procedure or this ultrasound is also used by sonometer. Also, in ultrasound, what the things happens here, what the things happen here, we just want to know how an ultrasound works. So in ultrasound, some events happen. What are the events? First of all, the ultrasound machine transmits high frequency. This high frequency may range from 1 to 10 megahertz. The machine transmits high frequency sound pulses into the body using a probe. What is probe? This is actually a transducer probe. We will try to see this part in the next portion of our lecture. So the sound pulses into the body using a probe. The sound waves travel into the body. Then the sound waves travel into the body and hit a boundary between tissues. Some of the sound waves get reflected back to the probe, while some other travel further until they reach another boundary and get reflected. So probe is a device that is used to generate sound at the same way is to catch the sound again. So generated sound gets reflected back due to some blockage, due to some boundaries, and then they just get reflected. The reflected waves, then these reflected waves are picked by the probe and relayed on the machine. The machine calculates the distance from the probe to the tissue. Here we by tissue means the boundaries due to which the sound gets reflected. So the machine calculates the distance from the probe to the tissue using the speed of sound in tissue and the time of each echo's return. As echoes are generated here, that means there are some specific time for the return of echoes. So machine will do what? Just make a calculation of the speed of sound and the time of each echo's return. The machine displays the distance and intensities of the echoes on the screen, forming a two-dimensional image. Thus, using the data, using the calculated terms, the machine displays a two-dimensional image, and that is just immersed on the screen. So this is the ultrasound process, how ultrasounds are created and how it passes through the body and it gets reflected, and how it just creates image. Then we will just try to know about the basic parts of of an ultrasonogram machine or ultrasonography machine. First of all, the most important part of an ultrasonogram is transducer probe. As we have known about probe, this probe makes the sound waves and receives the echoes. The transducer works using a principle called piezoelectric. Piezoelectric means pressure electricity effect. Piezoelectric effect. Using this principle, the transducer works. In the probe, there are one or more quartz crystals called piezoelectric crystals. When an electric current is applied to these crystals, they change their shape very rapidly. The rapid shape changes of crystals produce sound waves that travel outward. Conversely, when sound or pressure waves hit the crystals, they emit electrical currents. Therefore, the same crystals can be used to send and receive sound waves. So finally, what we have known about transducer probe is this probe is used for generating sound waves, and at the same time the sound gets reflected from different blockage, different boundaries of our body, and these reflected waves are also received by this probe. Next, the next part of ultrasonogram is CPU, central processing unit, that does all of the calculations we have just discussed earlier, that the speed, the time related to ultrasonogram or related to sound wave, and these calculations are done on the CPU or central processing unit. Next, part is transducer pulse controls. It just changes the amplitude, frequency, and duration of the pulses emitted from the transducer probe. For different kind of diagnosis, different kinds of probes are used. If you just see on the just have a look on the diagram of ultrasonogram machine. Here are the parts of it: monitor, transducer, keyboard, CDR-TVD drive, pulse controls, onboard computer, and beside of this another diagram is included here. Here look at here for vaginal experiment. The vaginal transducer are used, and for abdominal purpose, abdominal examination, the abdominal transducer are used. Here is a diagram related to transducer. So from our figure you just can see the number 4 part is display. Displays display means this is used for displaying the image captured by the ultrasonogram machine or by transducer. And keyboard are used to input data. Disk storage device stores the accurate image. What image is captured by the machine, that is stored in by disk storage device. And finally the printer just prints out the report for our diagnosis. So these are the basic parts of ultrasonogram machine. An ultrasonogram machine, we have seen the basic parts here. First one was our transducer probe, then CPU, then transducer pulse controls, display, keyboard, disk storage device, printer. Some other parts also just remain in ultrasonogram machine. We are just trying to focus on the major parts here. So these are the parts of an ultrasonogram machine. If we want to see the total process as a block diagram, here is a block diagram of an ultrasound machine or ultrasonogram machine. CPU, keyboard, disk storage, printer, transducer that is directly connected to the body, the parts that should be examined, and Here you can see transducer just contain piezoelectric crystals which are in contact with the body portion that will be examined, and that has a direct connection with CPU. And after monitoring, after calculating all data, all calculations, the final image is displayed on the display. So the image can be two-dimensional, three-dimensional, according to the type of examination. Different kinds of image can be formed by ultrasonogram or ultrasound machine. So this ultrasonogram machine is very familiar for gynecological diagnosis, and for urological treatment, for cardiological diagnosis, etc. And now let's try to know about the uses of ultrasonography. In gynecology, the most prominent uses of ultrasonography is in gynecology, then in cardiology, measuring blood flow through the heart and measure blood vessels, in urology, measuring blood flow through the kidney, seeing kidney stones, detecting prostate cancer, etc. And in gynecology, the most important use is to know about fetus, the position of fetus, the condition of fetus, and the size, position, etc. can be determined by ultrasonogram. So we have known two important diagnosis element in today's class. The first one is X-ray machine, and the second one is ultrasonogram machine. We have known different parts of these machines, the X-ray generating process, and in ultrasonogram how the sound is used to take image of a specific portion of our body. I think you have understood the topic or understood the points here. If you have any kind of problem, you can just ask through the comment section related to this class, and try to review your chapters again, and hope you will have a very good preparation for your upcoming exams. So all of you guys just stay safe and just have a good preparation for your exam. Thanks to all.